Hello everyone, and welcome to another video presentation courtesy of the University of North Texas Physics Department with the assistance of the Physics Demo Room. My name is Corey Nuck, and I'll be assisting in today's demonstration having to deal with liquid nitrogen and really volume expansion and how do objects change when it comes to extreme cold. So what we're going to be using as our catalyst for extreme cold conditions is just some liquid nitrogen. As you can tell, hopefully a little bit chilly, at least on the outside. But liquid nitrogen is really a unique substance in that it boils at 77 degree Kelvin, which is a negative 195 degrees C, which is a negative 320 degrees F, which for anyone at the University of North Texas that says that 32 degrees cold, this guy would beg to differ. Also anyone from places where it gets to negative 32 degrees Fahrenheit during the winter. But today we're going to be looking at some objects and seeing what will actually happen to them. Well, thank you for your patience. So what I have in front of me to do next with our little experiment, I have to take off the gloves for a second, is I've got a sour pickle. So what we're going to do is we're going to do two experiments. One, I don't have a banana, but I do got pickle juice squirting everywhere. So what I'm going to do is I'm going to pour out the pickle juice. I will admit, I'm not a huge fan of pickles. So this is going to be a little bit satisfying, because what we're going to do next is we're going to see if maybe due to all the water slash juice that this pickle has, see, pretty elastic. I can bounce this hammer off the pickle, no problem. It's bouncy. It's almost elastic. But now what I'm going to do is I'm going to take this pickle and I'm going to put it inside this liquid nitrogen for a while. So remember that this steam that you're seeing, or this condensation, or this fog, is really the liquid nitrogen boiling. And that's all that we're seeing. It's just the boiling because it's at such a low temperature that the liquid will turn into a gas and be converted into energy. And we kind of see this quasi-phase change right here through the fog because you have the hot air mixing with the other energy. Man, I love doing that. So I'm going to wait for this thing to be a little bit more because I really want to make sure that this actually works. Because then I'm going to do two more experiments to show how other properties going to work with matter. Now, a lot of people have seen this done with, like, say, flowers or with a banana, but I really wanted to try this with a pickle, just because, well, sometimes you get put into a pickle and you just want to see what happens when things get really cold. So, hopefully, yeah, that feels pretty hard to me. So I'm going to move this guy out of the way, that guy out of the way, and now, pretty good squash. Pretty good squash. So let's see if we can do this one more time. Didn't work that well with that, but let's just see if we can do this one more time. Maybe if we took off part of this pickle. Let's see if maybe we can do part of it. Let's see if we can really get this thing to smash. And then next, we'll just try to see how well will the pickle juice freeze. And finally, I've got this little vial of hand sanitizer. And we're going to see if the hand sanitizer will freeze and go into this other state as well. So again, this all has to do with how the water is interacting with this really cold air, causing things to contract, and then when you put it into a new temperature before that, we can smash it or not. But I can definitely tell when I pulled it out, everything was hardened, so it seemed a lot easier because you saw that I almost did the exact same amount of force, but instead of bouncing, it just went almost straight through it. And I'm using this piece of wood right here to kind of help me make sure this table doesn't get as damaged. And I can already tell that that thing's starting to get hard as a rock. There we go. That's better. Let's try this one more time. Last piece of pickle. Really frozen. starting to kind of go like that. Boom, we got our frozen pickle smashing. Really wish that would have been the first time, but we've got it working still the same. So now, what I'm going to do is I'm going to have a vessel to kind of do this. Now, hopefully this shouldn't break on me, and if it is, I'm going to try to do this in a controlled environment as possible and stay back a little bit. So I'm using a container to help get us to freeze the pickle juice. Now that container should be fine because I don't have it closed off on the top. Just like what you might see with other demonstrations, if I close off that top, you now have all this air, you have this pressure that it wants to possibly release, and that's not really good. So I'm going to let this thing just kind of go for a little bit, and we'll see if we can maybe slide out that pickle juice from inside the container. This has been a lot of fun. No, close, but it's getting there. Let me just put it in there just for a little bit longer. Again, this is the first time that I've been doing these experiments, so you're seeing the process just as much as I am. But I'm really glad that this guy did get smashed pretty good. And as you can probably tell with this, is that you see some parts that are actually completely frozen, and some parts that are still not. So if I probably would have let that in there for even longer, it would have continued, as you can see here. I'm going to let it keep going a little bit longer. Yeah, and this guy really got frozen. Now for another test. Ah, that looks more like a slushy. So let's see. Ah, not so much there, but maybe you can tell here, I've got some pickle residue on the side of this glass. Well, thank you for watching this video presentation on change of states with volume expansion, thermal expansion, along with objects experiencing extreme cold temperatures. Thank you for watching this short video presentation, and have a wonderful day.